Hello viewers, welcome to Opabene's math class. Let us base our today's tutorials on this particular question. The question says, solve for x. 16 raised to the power x is equal to 64 raised to the power x. Under this question, we are going to use two different approaches to solve this particular question. First of all, we are going to apply the law of indices to solve for x. And then secondly, we apply the law of logarithm to solve for x. So here, using the law of indices, we write our solution. Solution. (16 raised to the power x is equal to 64 raised to the power x. So first of all, we need to apply the law of indices. So here what we have to do is that we realize that 16 raised to the power x is equal to 64 raised to the power x. So here we can send 64 raised to the power x to the left side of the equation. So here we get 16 raised to the power x minus 64 raised to the power x is equal to 0. Remember, 16 can be put in a form 4 raised to the power 2, because 4 raised to the power 2 will give us 16. And then 64 can also be put in a form 4 raised to the power 3. So here 4 raised to the power 3 will give us 64. And then 4 raised to the power 2 will give us 16. Therefore, 16 raised to the power x minus 64 raised to the power x is equal to 0 can be seen in a form 4 raised to the power 2 all into bracket raised to the power x is equal to, 4 raised to the power 2 all into bracket raised to the power x minus 4 raised to the power 3 all into bracket raised to the power x is equal to 0. So here, this one can also be put in a form 4 raised to the power 2 into bracket raised to the power x minus 4 multiplied by 4 raised to the power 2 all into bracket raised to the power x. Remember, 4 without power is power 1, and therefore if I have 4 raised to the power 1 multiplied by 4 raised to the power 2 is the same thing as 4 raised to the power 3 according to the law of indices. So we then equate this one to 0. And remember, we have to spread this x for this 4 raised to the power 1 multiplied by 4 raised to the power 2. So in the end, we get 4 raised to the power 2x minus 4 raised to the power x multiplied by 4 raised to the power 2x is equal to 0. So here, what we have to do is that we need to factorize, because there's a common factor here, 4 raised to the power 2x and 4 raised to the power 2x. So we need to factor 4 raised to the power 2x out. So here, we get 4 raised to the power 2x outside the bracket into bracket. Here becomes 1 minus this one, 4 raised to the power 2x. We have to send this one. It's already sent outside. Therefore, here, remaining 4 raised to the power x is equal to 0. So here, we can take 4 raised to the power 2x and we equate to 0. And we then take 1 minus 4 raised to the power x and we also equate to 0. So this implies that 4 raised to the power 2x is equal to 0. But remember, 4 raised to the power 2x can never be equal to 0. Because when I put 1 to replace x, I can get 4 raised to the power 2. It can never give us 0. So 4 raised to the power 2x can never be equal to 0. Again, when you look at this one, 1 minus 4 raised to the power x, you also put that one equal to 0. So here we get something like 1 minus 4 raised to the power x is equal to 0. Remember, 1 minus 4 raised to the power x is equal to 0. We can send minus 4 raised to the power x to the other side of the equation. So when we send this one, it becomes positive. So in this case, we get 4 raised to the power x is equal to positive 1. So we then decide, here we have 4 raised to the power x is equal to 1. What number raised to the power 0 will give us 1? So remember, we have our base here to be 4. So we can put 4 raised to the power 0 here, which will represent 1 because of this 4. So here we have 4 raised to the power x is equal to 4 raised to the power 0. So here we can conclude by saying, because we have equal base and we have equal sign in between them, then we make use of the exponential terms. So here we have x is equal to 0. Therefore, the value of x is 0. Let us also apply the law of logarithm to solve this particular question. So here, using the logarithm method 2. Using the logarithm, we have 16 raised to the power x is equal to 64 raised to the power x. So we need to apply log on both sides. So here we have log 16 raised to the power x is equal to log 64 raised to the power x. So according to the law of logarithm, we have 16 raised to the power x with base 10, log base 10. Therefore, we send x to be the coefficient of the logarithm. So here we have x log 16 is equal to, the same thing applies to this one. So we have x log 64. We can therefore send x log 64 to the left side of the equation so that we get x log 16 minus x log 64 will give us 0. Remember, we have common factor, which is x. So we have x here and we have x here. So we have to send x outside the bracket. So this will appear like x into bracket log 16 minus log 64 is equal to 0. So here, using the law of logarithm, we have x into bracket log 16 divided by 64. This is equated to 0. So here we have two possible options. Either we divide both sides by log 16 over 64, or we reduce this to its lowest term. So here we can say x log 16 will go into 16 1. It goes into 64 4. So we have x log 1 over 4 is equal to 0. So we can therefore divide both sides by log 1 over 4. So this will appear as x is equal to 0 divided by log 1 over 4. But remember, any number divided by, when we put 0 and we divide it by any number, we still get 0. For instance, if I put 0 divided by 1, our answer will give us 0. So in this case, 0 divided by log 1 over 4 will still give us 0. And therefore, x is equal to 0. So the value of x is 0. So when we look at the previous method, when we apply the law of indices, we had x is equal to 0. So we can see from here, x is equal to 0. And then using the application of logarithm, we also had x is equal to 0. So whichever method that you think is easy for you, you apply it. So viewers, that is where we can end today's tutorials. So try and subscribe to my channel for more interesting videos and share it to your learner colleagues. Bye bye.